coming up.
Yeah. Just a heads up too, guys. I've got to duck off at about 10 o'clock for a team meeting. Just want to let you know.
That's right. Yeah, you did mention that to me, Chris. So maybe if Daniel could just do a very brief introduction, and then we'll move on to Chris, and then come back to Daniel.
Yeah, let's get started, I think. Morning, everyone. My name is Daniel. I'm an engineer with the operations technology team. I work very closely with network operations. In fact, I'm involved in operating the water and wastewater network as well at Southeast Water. So without further ado, I guess what I'll do is I'll start sharing my screen and show you what the Lentic platform is all about that we use to actually manage the network of meters that we have in the Southeast Water network. I might actually just stop my video just to make sure. Now, please let me know when you see my screen, some colorful graphs on there.
Yep.
All right, perfect. So what you're looking at is basically the landing page for the Lentic platform. What I'll do today's presentation is try and cover the entire life cycle of the meter. So basically how we onboard and activate a digital meter, how we use Lentic to actually group meters for certain activities, maybe like configuration updates, how we manage the meter network and its alarms. And finally, I'll try and show you quickly how we use some of the other business intelligence tools to give us a good overview of network performance as well. So let's kick off by, and I've already got some of the tabs open here, so I'll directly jump into them. What the process starts with onboarding a device. So now what happens is metering and BTS teams actually upload manifest files that has all the information with regards to, let's say, properties, what are the details of the meter, communication details, etc. And that's uploaded into a manifest file that is then loaded onto the IoT platform. Now, any meter whose details have been preloaded into the system after that could just be in the back of a truck, and you can commission these on properties. The moment they start to deliver their payload, you'll basically have them come up as active, and I'll show you what I mean by that. So on this tab, this is basically a device management tab. You've got basically the total number of devices you've got, how many are active, how many are pending, meaning only the manifest files have been uploaded, but they have not been installed yet, and how many we've isolated for XYZ reasons from the platform as well. So the platform gives you the ability to remove some devices from monitoring as well if you wanted to. And so basically it's just going to be plug and play from there. So once you've got all that loaded into the system, fairly simple. The moment our installers go out, commission a meter on a property, the next day it delivers its payload and its status changes to active, and pretty much from the next day you can start monitoring all the data that it's sending through. And that's what becomes an active meter on the platform side. Now, just being mindful of time, I'll try and move on. So that's a little bit about the device management side of it. Obviously, these devices have templates, and I'll just quickly show you. So let's say you could create a device template depending on the attributes and specifications, which could include things like telco information, configuration setup, what was the manufacturer of the meter, model, etc. And that template will then serve almost as a blueprint that you could deploy to as many meters as you wanted. And you could name it anything you wanted, preferably something logical. For instance, we use things that can tell us within the template name what manufacturer it is, if it's got a pressure sensor, things like that. So follow some sort of a naming convention there. What I'll touch on next is basically the creation of groups. Now, this is an important one from network operations perspective as well, and I'll try and show that to you. So what I can do, so I'm on the device screen again, and what I can do from here is I could create a group. So I could basically, let's say you wanted to create a group for one of the areas you service, so Moreton Bay, let's say, and you create a group of 500 devices. So you've got, for instance, let's say that's Moreton Bay for now, and you could create a group based on what suburbs within that you have, what telcos you wanted to focus on for any reason, any particular device you wanted to do. So you could have all this mix and match of different filters and attributes and use that to create a group. And you could then call it, all right, so I've got a group that I want of all the meters in there. I'll call it Moreton Bay, et cetera, et cetera. And I'm not going to do that right now, but I've already done that in the back. And got here is the Moreton Bay group here. So I've got about 500 devices in that. And I can try and show you what these devices would be. So all the devices that you would have put in here would show up. You could add or remove devices if you wanted to. Now, why would you create a group is probably the question. So basically, let's say you had an area that you were getting reports of pressure issues. So what you could do is you could create a group and you could change the configuration on all of those meters within that group and say, you know what, by default, the meters are giving me, let's say, 6 readings in a day, but now I want 24 readings. So I want a reading every hour, let's say, for a pressure sensor. And you could then start to analyze that data in a bit more granularity and sort of get to the bottom of the problem and say, all right, I think we're seeing okay trends here. We're not seeing that great here, things like that. And that's what the creation of groups allows you to do, basically.
Could I just ask how many, do all of your meters have pressure sensors, or are you every second, third, something like that?
So at the moment, we don't have pressure sensors on all meters. We're going down a path, as in this is an operational decision, of course, that we're trying to make, where we say, look, maybe we could have 2 per shut block. That might give us a decent coverage. Maybe have meters on the highest elevated properties with pressure sensors, sorry. And anything that can give us decent coverage of the meter so that anytime a caller rings through and says, look, I'm experiencing pressure issues, we have a meter close by and we say, look, in your block, we've got 2 pressure sensors and we think they're both normal. So it's probably something on your end. So it kind of gives you that initial level of vetting without even going out to the field.
Okay.
So
do you have additional pressure loggers or anything through your, I'm assuming you have DMAs set up?
Correct. So we do have pressure sensors along our network that we also use to monitor the pressure, of course.
Okay.
Yep. And what should I touch on next? Try and show you the config side of it as well. So what I'm in now is the same device type, and I've selected the device group that I had. And what you're seeing here is basically the config details, and you've got all the parameters. Now, for those of you interested, this is all picked up from these resource IDs that you see, these codes. They're all picked up from the lightweight M2M protocol, which basically defines our application layer between the device and the platform. And you could make changes to these. For someone who knows what they're doing, they could make changes to these and says, yep, pressure readings, I'm going to have them send in more frequently, or battery level, I want to know what's going on. And you could change those from here and apply that config to pretty much the entire group of your meters as well.
Daniel, just thinking, just mindful of time, might just pass over to Chris because I know he needs to leave at 10 o'clock, which is only 15 minutes, and then we might come back to you if that's okay.
Sounds perfectly fine, no problems. Over to you, Chris.
If you just want to unshare, Daniel, I'll just share my screen as well and pick it up from what you were looking at in that platform.
Yep, back to you.
Yeah, so what I was just going to show you guys, so Dan was just showing you in terms of some of the things available through the device menu. I was just going to point out, so within the alarms menu, there's a range of different alarms that come back into Southeast Water from the meters. Just bear with me one sec. Can you guys see my screen?
Yes.
All right, so down the right-hand side, you've got a range of different alarms, including a continuous usage alarm, tamper alarm. There's various other ones in there, but the one that I was just going to highlight is the continuous usage alarm. And what this is showing, so this is part of the daily payloads of data that come through. And just at the moment, this is telling me that there's actually 16 active continuous usage alarms on the meters in our network area, bearing in mind that we only have about 3,500 active at the moment. That number's doubled in the last probably 6 to 8 weeks. Things really stalled during COVID, during the lockdown, but we have starting to get a few more activated out in the field now, which is good. So we've got a few more of these alarms starting to come through. And I guess we've set up an automated workflow to manage how we want to handle these continuous usage alarms. So this is like a inbuilt capability that's, for every customer that has a digital meter on the property, the continuous flow alarm is automatically activated. And the way it works is if the meter's got anything above, if it's registering a flow of at least 5 litres per hour, or 120 litres a day for a period of 24 hours, then the meter will send an alarm back into this platform here. We then have a workflow that then determines whether a notification needs to go to the customer. So I might just quickly show, rather than going into each of those individual alarms, I just want to talk to that workflow just for a second. Bear with me one second. I'll just flick across. Are you guys able to see? I've just brought up a PowerPoint slide. Are you able to see that?
Yeah, no problem.
Yep.
Yeah, we can see it.
All right. So this is just showing that. So we've got the events that come through from the digital meter, a number of different events. We'll talk about the continuous usage event for the moment. That comes through to our systems. We then have a set of rules. So within this workflow that we have in place, a set of rules that determine whether we need to turn that alarm into a notification out to the customer. And that will depend on mainly on what the flow rate is. So the rules that we've put in place, and this is based on some trial results that we saw in the in one of our suburbs last year. We've set it, I guess, at a threshold level of at least 1,000 litres a day. So anything, if the continuous flow is recording at over 1,000 litres per day, which is, I think, is about 40 litres per hour, then that's what we consider a large leak. Anything below 1,000 litres a day is considered a small leak. Now, we can always tweak those thresholds as we go, but if it's a large leak, what it will do is it will automatically generate a notification out to the customer on the same day. And so we have, I guess, through this workflow, it actually turns, so from that platform that Dan was just showing you there before, it passes through a number of systems and comes out in our CRM system that's, we use Salesforce, or internally known as Pulse, but Salesforce is probably a more common system, that's more widely known. We have I guess we call it a continuous usage case that sits there in Salesforce. And if it's a large leak, it knows that, okay, yeah, this one we need to get a notification out immediately. So at the moment, the default channel that we use, if the customer has an email registered with us, we'll send a notification via email. If they don't have an email, but they've got a mobile, we'll send it via SMS. Or if they don't have either, then we send a letter out. We'll also send a letter if we've tried sending it via email or SMS and it's bounced. We'll then, by default, it'll come out as a letter to the customer. So yes, it's same day notification if it's a large leak, but if it's below that 1,000 litres per day threshold and it's a small leak, then what it'll do, it'll actually just sit there as a case for 7 days. If it stays on for at least 7 days, then it will send a notification out. So that hopefully just sort of, just showing there that, yes, so we don't send a notification every single time. There's a bit of vetting that happens there, and those rules are built in.
Can you give an idea of the extent of the automation of that? And I think, just for context, the reason we tried to automate this to the extent we could is when we have 800,000 of these meters out there, and what we found is there's between 10 and 15% of residences have a leak. It's an extraordinary amount of notifications and issues to handle, and our call centre will get smashed if we don't do it properly.
Yeah. Absolutely. So Dan, that's part of the, I guess, the rules and part of the learnings that we're trying to figure out as we go. And we've really used a lot of the learnings that we had from the proof of concept. So we had about 600 meters installed in the Frankston area last year, and we were monitoring those carefully to see what was going on, because we don't want to underreact, but we don't want to overreact either. So one of the drivers, I guess, is particularly for the smaller leaks, is how long would it need to be on, and what sort of dollar impact would we need to see before we need to really take action. And it is something, as I said, that will need to evolve as we go. But I'm just trying to show within this slide here how we sort of break it up a little bit. So we actually send up to 3 for any one continuous flow event. We're going to send up 3 notifications to the customer. And this is just explaining how it's sort of broken down between the small leaks, large leaks, and what the various impacts on the customer are at that point. So for a small leak, after about 7 days, on average, it would have had an impact on their bill of about $10 by that point. By the time we get to the second notification, so if it's then, if it keeps going for a further 7 days, then it's at the point where we would send a second notification, and by that stage, it's roughly $20 on average impact. And then by the time, by the third contact, that's a further 14 days after the second one. So it's, if you like, for small leaks, it's day 7, then day 14 we send a second, and then day 28 a third one. And after that, we don't send any further notifications. We really don't want to bombard them or inundate our contact centres. And then with the large leaks, as I was saying, so the typical impact, even on day 1 is somewhere between around $7 to $10. But if with a large leak, if that keeps going for a further 7 days after the first one, you're talking, around about $65 to $70 impact by that point.
Chris, when we send those notifications out, we estimate the amount of money that they're using for the leaks, don't we?
Correct. Yeah. So these figures I'm using here are just based on average impacts, based on average flow rates for a small leak or a large leak, based on what we've seen so far. But when we send the notification to the customer, it's reasonably, look, it's an estimate, but it's reasonably close, and it's based on what is the flow rate at the time that we trigger the notification. And what we actually say to them in the notification, we based on that flow rate, we say, okay, this is how much it would impact your annual bill by in terms of dollars and in litres. And the reason that we do that is that we are trying to motivate them to actually do something. We thought about, okay, do we do it as a tell them what the daily impact is? Do we tell them what the impact on the next bill is? Or do we say, okay, if this was to keep going, this would be the impact on your annual bill? And we made the call to go and say this is the impact annually. So far, in terms of the response from customers, and I guess our main aim is to actually motivate them to do something about it and fix the leak without swamping our contact centres. And so far, it's working quite well. That we are getting the vast majority of customers are responding pretty quickly and doing something about it, especially for the large leaks.
Sorry, to stop there, Chris. Any questions on what Chris has said? Just conscious he's about to leave.
No, nothing for me, but that's very insightful. Yeah, it's great. Is there any chance you might be able to share that presentation with us later? There's some really useful information on those slides.
Absolutely, yeah. So those, those 2 slides there. I mean, there is some, some other, a couple of other scenarios, but that probably highlights, the main things there. And the only additional thing we do for a large leak, when it's at the stage of where it's ready for a second notification, we also do a follow-up phone call. So we have a team of about 6 staff who are dedicated to handling digital inquiries, so that we set up a task for them to actually call the customer. But that's really the only time that we would actually make a follow-up phone call. We're really trying to use that automated workflow, and either by email or an SMS. And we also want to bring in the capability for customers to be able to register their preference in terms of contact. That's coming pretty soon. The other thing that we do is at the stage of a second, so the first notification will just go to the occupier. So if it's an owner-occupied property, we just send it to the owner. If it's a tenant property, we send it to the tenant for the first one. But if it keeps going for a second notification or a third notification, if it's a tenanted property, we notify the tenant. We also send a copy to the landlord, because we know that in most cases that it's probably going to need the landlord's okay to go out there and repair it. So that's a little bit of info about that. And the other thing in the notification, I mentioned about some of the figures that we put in there to try and motivate the customer to do something about it. The other thing I can just quickly show you is we really do try and encourage them to go to our customer portal to have a look at their usage, and they can see for themselves and even self-diagnose what's actually going on. So I'm just going to quickly see if I can share the portal with you guys. Bear with me one sec. Can you guys see that?
Yep, the usage.
Yep. So this is so when the customer actually logs in, if they have they've registered their own account in the customer portal through the Southeast Water website, they can go into this usage tab up here, and they can either get a daily view of their usage, or a weekly view, or a monthly view. The view that I'm looking at, so this is showing me for this week, so over the last 4 days, if I was to hover over any of these bar charts here, it tells me what the usage is. So I can see it day by day, if I want to look at see what's going on for that month, which is particularly useful if they're calling up and they've got a inquiry about their bill. We can sort of see how things have been trending. Or if we want to go down to the daily level, like if we've sent them out a notification and customers calling us about that actual notification they've received. For example, if I look at, if I go to a more recent, but this is actually, so this is by default, this is showing me Tuesday the 1st of December. So we can actually see hour by hour what's going on with their usage. And I know that in the case of this one, there's not continuous usage on this one because it's, we've got quite a few little intervals here where there's no usage recorded at all. So with a continuous usage, I'd be looking to see, have you actually got usage recorded across every hourly or half hourly interval? So that sort of view, that's where we really want to direct customers to go first. We also give staff, like we've got an internal view set up where staff can actually go in and view the customer's digital usage data as well, and go down to the daily level so they can drill in and help see what's going on there. So guys, I'm going to have to run, but I'll leave it at that. But hopefully it gives you a bit of an idea in terms of thinking in terms of where we want to go. But we've got a fair way to go yet. A fair bit of learning. But happy to send out those couple of slides that I showed before to give you an idea as to how it works.
Fantastic, Chris. Well, if you could pass those slides to me, I'll pass it on to Unity Water.
No worries.
Any questions for Chris before he jumps?
No questions, but thank you, Chris. That was great.
No worries, guys.
Thanks, mate.
Enjoy. Catch you later.
Yeah.
See you, Chris.
Back to you, Daniel, I think.
Yeah, I'll take over. Right, so I'll just pick up where Chris left off from. So back to the alarm screen. And one thing that's probably important to know here is from a network management perspective, of course, you want to be able to monitor the different kind of alarms you get from your digital meters. We've got low and high pressure alarms that come up. Now these are based on the meter itself. It's based on going plus or minus 5 meter head, let's say, for low pressure or high pressure. And of course, you could change that if you wanted to. We've also got tamper alarms. Now I'll touch on, I think Chris already mentioned about the continuous usage alarms. They're pretty straightforward, but they're more for a customer side leak rather than anything on information regards to the network. However, from a network perspective, you could have these empty pipe alarms, and these can actually pretty much immediately, because these are set up in real time for us, this can pretty much immediately tell you there's not enough water in the customer's pipe. And when experienced in clusters, let's say, this is basically, it could tell you that water is off for a certain area, and that could be because we've got contractors doing works on site, or that could be something completely unplanned. So pretty much in real time, you'll have a very good indication of what kind of impact a particular leak or a burst has had, for which people have had to shut down the water, etc. And you've had, let's say, 1,000 properties affected by this shutdown because of that burst. So yeah, it gives you that total assessment pretty much immediately, and you can get it directly from the Lentic platform itself. So some of the meters that you see here in red have been isolated for different reasons, which is why they come up in red that way. And this is what I want to come down to next. So we've got a tamper alarm, and this is important again because the meter being our asset is something we want to make sure is being safe, has not been tampered with, and the tamper alarm can be generated even if someone just knocks a meter, maybe drops it from, let's say, a 1 meter height, or someone reverses a truck into it and things like that, just to make sure that our meters are in good condition. The tamper alarm comes up. Even if someone tries to bring a magnet near to it, you could generate that tamper alarm. And what we do is when we've got a tamper alarm, we try and follow up with the customer to say, look, we noticed so and so. We can even send out one of our own crews to site to say what happened here. And if it's something that needs replacement, you could then isolate the meter from the platform if you wanted to. And yeah, that's pretty much the last step really that you want to do from the platform, is isolate it. And I think with that, we've pretty much covered how we onboard stuff, how it shows up on the platform as an active meter. how we move on to create groups for it and make changes if we wanted to in a group in a network operations perspective as well. And finally, how you could isolate it if you wanted to. And I think I've also shown you some of the codes, the lightweight M2M protocol codes that we use that you could use to change configuration remotely as well. Finally, I think I want to show you guys some of the very good work that we've done on, now this is what we've done on Power BI. All that is platform centric, and this is more to do with, let's say if a manager was interested to know how your meter network was doing today, what was the responsiveness of the meter, how many meters have you got that are unresponsive, basically just to check your SLAs in terms of network upkeep and healthiness. And you could come to some of these reports that we've made on Power BI to tell you, right, that's the number of active meters we've got. Out of those, we've got 94% active. Some of these have missed their payload. So payload missed is basically to say, like in the last 24 hours, you received nothing from the meter when you should have received at least one transaction. And likewise, unresponsive is anything that goes on for more than 48 hours. And flickering is in the last 2 to 5 days, in the last 7 days, sorry, you've got about 2 to 5 payloads only. So that's a meter that's dropping off every now and then. And you could pull up a list of all of these to say, how many have you got that are unresponsive? How many are flickering, payload missed, etc. We've also got alarms that correspond to all the unresponsive meters. So you could club them together and get your crews out to say, look, this is a list of all the meters that are showing as unresponsive. So-and-so have been unresponsive for the last 10 days. And I think we need to go out on site and look into them. We could get our internal teams as well to have a look first to say if they're even communicating with on the telco network. And if they're not, then it's something that needs to be attended on site. I think the last thing I want to show you guys is relevant to what Chris was mentioning as well. And this was a platform that I got, this was a report that I got made through the data analyst on my team. And with the meters giving you all of this really good data for usage, we get half-hourly intervals of flow from the meter. And what you could do with that is, now Chris's notification would be sent to customers if it's above a certain threshold, like Chris was mentioning. However, you could pick up even minor leaks just through the data that is coming through. So for instance, if I show you here, I've highlighted this meter, and that is just giving you about a liter every half an hour. So that's about 2 liters per hour of usage on this. And it seems to be gradually increasing. And this is what you could pick up. This would never generate an alarm because the meter has a threshold of 5 liters per hour. And this would usually never generate an alarm. But if you wanted to, you could do some data analysis and actually pick up things like this. And we've got heaps of these as well that with the population of meters that we have, that we're picking up so many of these cases. Like this one's at 10 liters per hour. Some of these might have an alarm. Some of these might just be on the threshold, so might not have triggered the alarm. But this report will pick up things like that to say, okay, you've got usage there. It's not going back to zero. That's the logic that we use. Usage that has not gone back to zero for any of the half-hourly intervals. If it goes on for longer than a day, pick it up in this report and you'll get very, very interesting results. So quite a lot of space. We also have plans to do in-depth pressure analysis for once we have enough meters out there with pressure sensors, we can do a pressure analysis for our entire network and say, okay, we've got this whole area that we service, and we've got these many pressure sensors, and let's see a trend of how pressures changed over time in the area. If there's something that we think relates to network operations, then we can have our crews go out and attend maybe the closest pressure relief valves, etc., just to make sure things are running as normal. So yeah, I think I've wrapped it up. I don't think there's anything else that I have to...
Daniel, there's no other questions. I just wonder whether the event management's worth touching on.
When you say event management, I think you're talking about, I think I can bring up, when you say event management, Dan, are you talking about alarms?
Yeah.
All right. So yeah, I think
so how do we, like, maybe just talk a bit about,
all right,
you know, how the rules are created and how we...
Correct. Yeah, I might actually show you guys some rules as well. So now we could have a rule set up. Let's say we've got this one, for instance. So whenever we set up new meters, and this is, again, when you've got a population that's going to span to hundreds of thousands of meters, you probably need a rules engine to manage some of the events that you think might be causing you a bit of a nuisance. So let's say when we install new meters, we've got, just to give you an example here, is let's say a low pressure alarm or a high pressure alarm gets triggered based on, right, you've got a new meter installed. There was no rolling average for it. So anything that it sees now triggers a high pressure alarm. So what we did was we masked that for the first 7 days and said anything after that becomes a genuine one, because that's the amount of time the meter takes to normalize to the value of the pressure. And once we pass that, we could create a rule to mask things like that. And over time, you'll come across if you experience or if you experiment with different meter manufacturers, let's say, or different telcos, different problems come up. And if you want to mask certain things, you could have a rules engine in place where someone could write a SQL query and pretty much create a rule, pass it through for approval, and pretty much you'll cover yourself on that end to manage some of those alarms and events, which would otherwise possibly be maybe annoying, which don't add value. And that way you just keep your alarms very clean and sleek, really. Yeah, that's a little bit on alarm side of it. If there are any questions, feel free. We've also got Salah on the line, who's an expert on the platform and the technical architecture of it as well. So
we did a session on the architecture prior to this with a different group, I think. But yeah, look, if anyone's interested in that, I don't know, Salah, is there anything you want to add around alarms?
The only thing I wanted just to say, not specifically on this architecture, is how does actually automation happen? So because we didn't really cover the technology behind that. So these alarms, which generated from rules, get.
Sorry, Salah, if I can just jump in. I think Bronwyn's got a question.
Yeah.
Actually, it's I've got Steve McDonald with me, so I'll hand over to him.
Hey guys, how you going? I just wanted just had a question around. You've got real-time alerts coming through. How have you got the meters configured? How often are they transmitting that you can get real-time alerts for pressure issues, etc.?
So we've got, so normally the meters communicate once every 24 hours. Yep. But some of the alarms have been set up within the meter to trigger in real time. So let's say the empty pipe one is a real time alarm. The pressure is not. So the pressure, like I said, is based on let's say a rolling average. And once the meter sees that it's fallen below a rolling average, the meter basically in the next payload delivers that low pressure alarm.
Okay, so the empty pipe, if it gets an empty pipe alarm, it wakes the meter up and sends an alert.
Correct, that's right.
Excellent.
But also, I think probably worth adding that we can configure these meters so that they can provide real-time alerts on any of the alarms should we wish to do that. But this is just how Southeast Water's configured it to balance battery life with data.
Yep, yeah, exactly, spot on.
Excellent, thanks guys.
Sorry, go ahead.
Salah, yeah.
So I just wanted to say, so I guess all this solution in Azure, and the result of all these activities, when you have an alarm generated, if it is real time, would be treated differently from process automation if it is slow. So we have two different activities, either slow or fast moving activities need to be actioned. So there would be another engine is going to come hooked to these events and basically pick that. So the continuous flow example before would be picked up by a process automation engine called Pega, and basically it will pick this one up, and then it will apply an orchestration and a workflow logic there. For example, if it is certain volume, this is what you do. If you don't get a response, you escalate to this. All that logic happens in the process management and automation engine, which is Pega. So if you see, I guess and we mentioned that last time, the end-to-end solution is consisting of multiple building blocks. What Daniel showed here is the portal and the user activities on that. Obviously, we want to automate as many things as possible, so Daniel doesn't need to look into, hundreds of thousands of activities and events. So I guess one of the message here is like kind of automation is really a key to be able to deal with this, because you're going to have a huge amount of data. And Southeast Water again implemented an end-to-end solution, including Pega as an automation engine, Boomi as a hybrid integration, all the way to the email notification. So there's multiple other, I guess, building blocks to make this seamless all the way to the customer portal.
Good. So yeah, that's probably the majority of what we wanted to share, but very open to any questions or follow-ups.
Yeah, Daniel, it's Alex here. I just wanted to ask, and I'm not sure who can answer. I didn't get to see the full recording of the last one yet, but I noticed on the screen you have Vodafone and Telstra, so they're your, I suppose, they're your vendors in terms of the connectivity, are coming through to the one platform. So that platform's overlaying both, receiving data from both of those networks. Is that right?
That is correct. That's
okay.
Absolutely right. Yep.
So that's what the Lentic platform's doing, overlaying both. So you're really only dealing with one.
Yeah.
Yes. So we don't have to go.
It's definitely worth looking at that past recording, because we go into a fair bit of detail about the architecture that we created was designed to give us freedom moving forward from new technologies that may come, but also multiple telcos, multiple communication types, multiple devices. So we basically tried to be as agnostic as possible to anything, and to avoid vendor lock-in.
Yeah, makes sense.
And so we might, for example, if we get a better price from Vodafone, where we have good urban coverage, is to have them for majority of the network, and then just use Telstra for fringe parts where maybe they have a greater network.
Yeah, no, that makes sense. And I think too, I know with in the platform being able to edit your own rules, so you're not reliant on specific vendors necessarily to go and do that. So you're doing that in-house, it's got that capability.
Yeah, it's all been designed for operators to use. It's an operator first platform.
Yeah, the two things is basically this is designed for the business, not for the technical guys. So the metering team, the customer support team could view this when the customer call and saying, why am I? So we expose some of that data to the customer support team, and also the OT team, obviously purely designed for people understand network, understand zones. We bring GIS data, we bring customer funds data and billing data into this. So it's a combination. It's a business tool. It's not a technical tool. I guess also, which is maybe really obvious, is centralization is really key here. So there's one source of truth. If you don't have this, and you say, for example, deal with multiple, different variation of devices or different variation of meter, you have to maintain subsets of this information at different locations and at different rules and at different things. This is all central. You do everything in one, and you push it to the communication layer. So the telco is purely communication layer. They're not really adding any business logic or business rules or validation or anything like that. They simply transport layer.
Yep, that makes sense. I think Ron's got a question, or Steve.
Hey, Steve here again. Just regarding devices, can you just run through the devices you use? I believe you use the 8Z. Are you using the Landis and Gear meter as well? And what sort of data loggers are you using on your larger meters? And are you getting the same sort of alerts from the data loggers with respect to obviously things like empty pipe pressure and backflow and those sorts of things?
Dan, you're on mute.
Using, geez. So I'm happy to take this one, but we're using a combination. We are device agnostic, but we've worked really closely with a couple of manufacturers, basically to get the firmware up to where we need it to be. But we made a clear decision to go with ultrasonic digital meters, and we also went with NB-IoT as a clear preferred communications platform. We also wanted our meters to have extra sensors in them. So our meters, in addition to monitoring the flow, they also do pressure, as you know now. But we've also developed our own vibration sensor, which effectively identifies and locates a leak in the network. And Lentic Gear is taking that technology globally, and they're putting it in their meters. So the two main base meters that we have in our network are the Wizong meter and the Lentic Gear meter. We have developed our own data logger as well, and that's going to be put on the larger mechanical meters, mainly industrial ones. And we have developed that so that we can have a whole bunch of different sensors in that as well. So we'll have cathodic sensors, pressure sensors, we'll have the vibration sensor, the mind, and it'll continue. And so that will be on NB-IoT as well, and that will all feed into the platform. So we'll be able to ingest and manage those devices centrally.
We onboarded some of these payloads from these data loggers, and the payloads, it's nearly identical to the lightweight M2M payload which we're receiving from the 20 millimeter from the digital meters. So as Dan said, it is a holistic system. So we would have that these loggers will be treated as devices. This is not a metering system. This is a digital device system. So you could add tomorrow a sensor or any other device in the network, or if you have a smart pipes or whatever that might come. This is not designed specifically for a smart meter.
Yeah, in fact, the plan is to move pretty much everything off the SCADA system into this system, except for critical assets, which will remain on the SCADA. But then that SCADA data will feed into the platform. Platform will be the central source of truth, or the whole central nervous system for the organisation, essentially.
So those loggers market ready, or are you still developing them with the sensors?
They're being tested in Southeast Waters network now, and but they will be commercially available 2021.
And are they sort of?
They're going to be an order of magnitude more cost effective than anything we've seen on the market, which is the main driver for us doing it ourselves.
Yeah, that was my next question. They're not really cost competitive at the moment, so yeah, that'll be a big plus.
We want to flood our market with sensors. We're building one at the moment for level for the sewage system, and so we've got a more sophisticated level sensor for really key points of the sewage network, but we can't afford to put it everywhere. So we've developed this low-cost logger that will sit in the manhole and that we can just flood the network with. We just want to get full visibility of our sewage and water networks. So the market wasn't innovating quickly enough. So we've got the resources, R&D lab to be able to build it.
Fantastic. That'll be yeah. I'd be keen to get a presentation on your sewer network. That's my next job. Once we've got the water network up and running, is to look at the sewer network. So
we've already got it up and running, the sewer network. So happy to about that when you like.
Yeah, it's out of scope at the moment, but yeah, I'd certainly like to have a catch up probably early in the new year, I guess, January, February maybe.
Yeah, let's do that, Steve.
Start talking high level initially. That'd be really good.
I mean, just one last, as you appreciate, this is all about data here. And what we're showing you today is the human interface and interaction with it. But in reality, this is going to generate lots of data. And that data needs to be mixed, not from time series only to structured and unstructured data as well. So behind this all going to end up in the data lake, the new advanced analytics platform, which also on Azure, which makes it really nice because then you could plug in different Azure services in and out. So this is the next stage we're currently working on. So as you move to AI, machine learning, getting time series, meter data plus SCADA data plus GIS data plus customer that enrichment to make some of these larger analytics capabilities to understand leak in the street or zone, or deal with population growth, or all of these things. These would really be turned on when the next building block, which is the big data and advanced analytics platform, which is we currently designing.
Alex, you're on mute.
Yes, thank you. It's 2020, a whole year of it. You'd think.
I know.
I was just going to say, pretty much that's at the heart of the longer strategic direction of where we want to go to. And I know I speak for Janae, and that is definitely in his sights and vision. So yeah, all this data, and I've worked in business intelligence before, so it is the way we're going to make better decisions going forward for our business and our customers. So this is just the start for us. So yeah, that's awesome.
The only thing I'd suggest is keep an eye on it now, because there are lots of overlaps. And so, for example, we talk about real-time, real-time analytics, for example. We talk about some of these things closer to the IoT, some actually sitting on the. So I think it'd be good, at least even for very, very small, but just keep an eye on the, like when we design architecture, we look into the big picture, everything, but then we design for locality. So I think I suggest that you actually consider these larger next steps now as well, but it doesn't mean you have to build them now, but you actually you have a vision about how this all going to come together.
Yep, absolutely. Awesome. Is there any other questions, guys? Ron, Steve?
No, I think we're all good here.
Yeah, and I appreciate your time, guys. It was really useful.
Thank you. It really is.
Thank you. Thank you for your time as well, and awesome questions. And we'll send through those 2 slides that you requested, and anything else that's that may be of use. And look forward to connecting in the new year. It's hoping 2021's the breakout year when all our dreams come true.
Yeah, definitely.
Yep. Maybe we can meet in person.
Yeah, that would be nice as well. We'd love to have you down in Melbourne, and we're in a beautiful part of the world in Frankston. Although I did notice that most of the Tampa alums are in Frankston. Any coincidence there?
Yes. Well, I'm a Melbourne-born girl, so I'll definitely be heading down to Melbourne in the new year anyway. And we've got family scattered, and some of them are in Frankston. So, let's hope that they're not tampering.
So when I go for my lunch break, when we used to be in the office back in 2019 and before that, you'd often see a few crimes happening on your lunch break. It's it's a funny place. But then you've got Frankston South, which is quite wealthy, and then there's the Frankston North. It's quite a diverse suburb. But I think it's not unusual for water corps to be in those types of areas, I think, and we got to be where the people are. So it's good. We'll look forward to hosting you when you come down, Alex.
Yeah, I might even get a footy game in. Absolutely, have to. Awesome. Thanks, guys. I really appreciate it.
Cheers.
Thanks
Cheers,
so
guys.
much.
Okay. See you later. Thanks.
See you all. Thank you.